Hey guys, I want to go ahead and talk about some more examples of using the sum and difference formulas. And I think the easiest way for me to do it is just kind of lay it out for you guys and just explain what I did. So essentially, this is the problem. It says let sine of u is equal to 3/4 and cosine of v is equal to -4/5, which are both in the second quadrant. Now the question is asking us to find this. Find sine of u plus v. So we start off with our summation formula, right? So we start off with this. Sine of u times cosine of v plus, okay, it stays with the plus sign, and then we switch it. Cosine of u times sine of v, okay? And so it just switches the angle. Well, when we start doing it, it tells us sine of u is 3/4. Well, okay, sine of u is this guy. Oh, that's easy. Cosine of v, okay, they give us that one, which is this. But what about cosine of u? We don't know it. So what you have to do is draw the triangle. So sine of u, you're going to have to draw the triangle, which is this guy, okay? Opposite over hypotenuse. So sine of u, they're both in quadrant 2. That's why I drew it in the second quadrant. Opposite is 3. It's positive 3 because it's going up. And then the hypotenuse is 4. With the hypotenuse is always positive. Now, when I do the Pythagorean theorem, I get plus or minus square root of 7. Because we're going to the left, we're going to use negative square root of 7. Okay? And then the same thing you're going to be doing with this guy, all right, with the second one. So I drew my triangle, also in the second quadrant. Okay? Cosine of v, so it's v is opposite. Okay? I'm sorry, adjacent over hypotenuse. So adjacent is -4. Hypotenuse is 5. Notice it's -4 because it's going to the left. All right? I do my Pythagorean theorem again. I end up with plus or minus 3. And now because it's going up in the second quadrant, it's positive 3. So now that I have my both triangles, I can go ahead and continue to finish the problem. Cosine of u is adjacent over hypotenuse. Sine of v is opposite over hypotenuse. Okay? So you notice you have to draw these two triangles in the respective quadrants. You have to use Pythagorean theorem in order to finish solving it. And then from here, it's pretty simple. 3 times -4, 4 times 5. You do the math, have the same denominator. You can put the numerators together, and that's all you have to do. And your professor should accept that as perfectly well. All right, we're going to go ahead and do another one, but this time I'm going to use secant. Now, secant is the reciprocal trig ratio of cosine. So what I'm going to do is I'm going to do cosine, okay? We're going to do cosine. And we're going to do the same triangles just for sake of time. But when I do them, I'm going to do the reciprocal. So cosine of u minus v. So cosine, I call them the cocos. So cosine of u times cosine of v. Instead of minus, it becomes a plus. And then we switch it. Sine of u times sine of v. And then, well, what's cosine of u? So let's go here, get that into focus. Cosine of u is, okay, adjacent over hypotenuse. All right, but because it's secant is the reverse. Instead of negative square root of 7/4, I'm doing 4 over negative square root of 7. You see that? And then what about cosine of v? Well, cosine of v adjacent over hypotenuse. So normally it's -4/5. But the reciprocal, it's 5 over -4. Because, again, they want us to find secant. Same thing with sine. What's sine of u? Opposite over hypotenuse. So 3/4 is going to become 4/3. Sine of v. Sine of v is normally 3/5, but it becomes 5/3. Okay? And that's what we're doing. So now it becomes a lot more simple. We're going to use our algebra. 4 times 5 is 20 over 4 radical 7 plus 20 over radical 9. Now, I wanted to keep doing this one just because I want you guys to continue to practice your algebra skills. If you notice here, 20 divided by 4, that becomes 5. 5's on the top, the radical on the denominator. Your professor might allow you to leave it like this, but we're going to go ahead and continue to do a little bit more work. We need the same denominators, and if you don't know how to find the same denominators, I teach my students to do something called Shupy. And what you do is you multiply the denominators, okay? So 9 times radical 7, it's not 63, okay? Because this is a whole number integer, this is irrational, so you're just going to put them together. All right, and how does Shupy work? You have a plus sign in the middle, plus sign in the middle. You're going to start over here, and you're going to do I think they call it the butterfly in elementary school, but 5 times 9 is 45. Radical 7 times 20 is 20 radical 7. So from there, you have this expression. But your professor's not going to let you leave a radical in the denominator. You're going to have to rationalize it. So we're going to just multiply by radical 7. Okay, so what you're going to do is distribute 45 times radical 7 is this guy, plus 20 radical 7 times radical 7. Square root of 7 times square root of 7 is square root of 49. Square root of 49 is 7. Notice the square root of 7 only multiplies the radical, not the 20. Okay, and so you end up with 20 times 7, which is 140. And then over here, same thing in the bottom. Square root of 7 gives you square root of 49, which is 7. And so that's your solution right there, okay? A little long, but essentially, hopefully you guys got the gist of it. So remember, you're going to have to draw your triangles. And then after you expand using your summation formulas, okay, make sure you do the reciprocal because it's asking for secant, all right? All right. Now, I want to go ahead and do the problem that I wasn't able to last time just because of the sake of time, and it just got kind of long. But these are what I call level 3 problems, very good college problems. All right. Sorry about that, guys. But essentially, we have cosine here. We're using our formula, okay, our summation. So cosine of x times cosine of pi over 4. Plus becomes a minus, sine of x times sine of pi over 4. That's just this part. This is just part of the first one. Now we continue to the second one. Same thing with this guy, cosine of x, cosine of pi over 4, minus, and then we do sine of x, sine of pi over 4 equals -1. Well, if you notice, you have cosine of x here, cosine of x here. We have 2 of those. Negative sine of x, negative sine of x. We have 2 of those equals -1, so we're condensing it a little bit more. And then cosine of pi over 4 is radical 2 over 2. Okay, these two are going to simplify out. We're left with cosine of x times radical 2. Same thing over here. Okay, square root of 2 over 2. And then you have the 2's that are simplifying out. Now we have this expression here. Well, what can we do now? We can factor out the square root of 2. Now we have cosine of x minus sine of x equals -1. Divide by radical 2. We have this guy. Remember, you cannot leave a radical in the denominator. We rationalize it. So that's going to go ahead and give me negative radical 2 over 2. Now we run into a bit of a problem because we have cosine of x minus sine of x. So what can I do? Well, we want to put everything in terms of one single trig ratio. So what you can do is you can square both sides. When you square the right, you should get 2 over 4 because radical 2 times radical 2 gives you radical 4, which is 2. Negative times negative is a positive. So you get 2 over 4. Over here, cosine of x minus sine of x squared, you're going to essentially doing your algebra 1, cosine squared minus cosine times sine doubled plus negative sine x times negative sine x is sine squared of x. If that still doesn't make any sense, essentially, guys, what you're doing is cosine of x minus sine of x times another cosine of x minus sine of x. And you're just distributing. So that's what you're supposed to be doing. But hopefully you know how to expand it in your mind. Well, now we have this, and that still doesn't help me out much. But now what you can do is think about your trig identities. Remember that sine squared plus cosine squared is equal to 1. Well, if I rearrange this and bring the cosine across, I get 1 minus cosine squared of x. Well, if you notice, I can go ahead and simplify it and substitute this guy here. Instead of sine squared of x, 1 minus cosine squared of x. Now, if you notice, cosine squared minus cosine squared, that cancels out. So I'm left with the 1 minus 2 sine of x cosine of x, which is equal to 1/2. Well, I bring the 1 across, becomes a negative. 1 minus 1/2 becomes a negative 1/2. So what I did next, or what you should do, is you divide both sides by negative, and you end up with just this positive expression, which is nice. We don't want to deal with too many negatives. But I'm still having a problem here. What's 2 sine of x cosine of x? Well, I would love to have it into one ratio. Well, if you notice, you have another trig ratio, which is called the double angle formula. And we're gonna use our summation formula. Let's say you have the same angle, x plus x, right? If I expanded using my trig, my summation formula, you have sine of x times cosine of x plus cosine of x times sine of x. Now, x is the same angle. So if you notice, you have double of the same thing. Sine of x, cosine of x, cosine of x, sine of x. This essentially is the same thing. So now you have 2 sine of x times cosine of x. So this can be substituted by the sine of 2x, which is here. So sine of 2x is equal to 1/2. Well, now you take the sine inverse. And what's the sine inverse of 1/2? Well, 1/2, you need one finger on sine. Remember, cosine's on the top, sine's on the bottom. If I'm going to have one finger on the bottom, you're going to have one here. What angle am I folding? Well, this is 30 degrees, which is pi over 6. Pi over 6. So you have two solutions. Because where is sine positive? Positive 1/2. It's the first quadrant and the second quadrant. Okay? And how do you get 5 pi over 6? Well, 6 take away 1 is 5 pi over 6. So you have two solutions here. Well, now we got to divide by 2 in order to go ahead and finish it. Well, dividing by 2 is the same thing as multiplying by 1/2. So pi over 6 times 1/2 is pi over 12, and then 5 pi over 12. And it's still not done. Now, we have to talk about the extraneous solution, because remember when we had this expression here? You notice how you squared it? Well, when you squared it, you have to check for extraneous solutions. And what you have to do is these two, when you plug it in here, you have to see if it gives you this value here. Honestly, the only way to do that is to check using your calculator. But when you do that, you're going to find out the only one that works is 5 pi over 12. And we call that an extraneous solution. So I know that was long, guys. It's a real good college problem, but I hope it helps, and good luck.